Start with taking up this section formula today. Let us draw a figure. Suppose there is a point here which is suppose represented by A and is denoted by x1, y1, and here you have a point which is represented by x2, y2. Let me just join these 2 points to make it a line. We are trying to find out a section of this, maybe here, which is dividing P, the coordinates being assuming x, y. This is dividing the line AB in two different sections or two different divisions. So how do we find this P, coordinate of P? The formula. Okay, this one is, I forgot to mention that this is when P is actually dividing AB internally. So the formula will be, let me write down the formula, then I explain what do they represent. The x coordinate of the P is represented by m1 x2 plus m2 x1 whole by m1 plus m2. This is the x coordinate. We'll similarly write the y coordinate, which is given by m1 y2 plus m2 y1 by m1 plus m2. Now let us understand what is this m1 and m2. m1 and m2 represents or mentions the ratio at which this point P is dividing AB. Suppose the ratio at which this P is dividing AB is 2:1. Then we can assume m1 and m2 being the ratio as 2 and 1. So m1 is to m2 is ratio at which it is dividing the line. And we know how we have referred this x1, x2, y1, y2 being the coordinates of the point A and B. This is the case when the point P is dividing it internally. Now if in the case this P is midpoint of A and B, that means what? In such case m1 and m2 they become 1:1 because MP being the dividing it equally. If you replace m1 and m2 in that case as 1 plus 1, we get the x coordinate as well as the y coordinate denominator being 2. And in the numerator, if you replace m1 with a 1, m2 with a 1, even in the y coordinate m1 with a 1 and m2 also being 1, we will be left with x1 plus x2 by 2, and here you will be left with y1 plus y2 by 2, which are separately called as the midpoint formula. Let me just write it down separately here as x1 plus x2 by 2 is the x coordinate when the midpoint is P, and the y coordinate is given by y1 plus y2 by 2. I make some space by raising this so that I can take up the next part wherein we discuss if this line is divided by P externally. Let me draw another small Cartesian plane and I show you where P stands in that case if it is dividing the line AB externally. This is A, this becomes P, and P is here at this point. This is P, this is A, and that's B and A. The coordinate representation will remain same as I have already taken them and the above explanation, so let it be as it is. Let's not disturb that and keep xy for P. In such case, what happens is the formula turns to be, for the x coordinate it remains m1 x2 minus m2 x1 whole by m1 plus m2. On the other hand, the y coordinate being m1 y2 plus m2 y1 by m1 plus m2. Oh, sorry, I made a mistake here. It should be a minus when it is externally dividing. This is the formula when for the section. This is called the section formula when a point is dividing a given line segment internally and as well as externally. Let's move on to take up question on application of this section formula. I'll take up a question wherein we calculate both of them together in one question, both internally and externally as well. Let me note down the question. Let me use some short notes so that I write the question fast. Find the coordinates of the point which divides the line segment joining the points. If you recall the figure, these points mean they are referring now to the points A and B, which we learnt in the previous figure, minus 3 and 5 internally as well as externally, and the given ratio is in the ratio of 2:3. This is referred to as M1 and M2. Let us first take the case wherein we'll calculate it for internal division. In such case, let me just note down, let P have this xy coordinate dividing AB internally. So for the formula, we'll write M1 to be 2, M2 to be 3, X1 to be 4, X2 to be minus 3, Y1 to be minus 2, and Y2 to be 5. Let us apply the formula to find the x coordinate. X was M1 X2 plus, if you recall, let us not write the formula again. Let me quickly replace or substitute the values. So it is 2 is M1, X2 is minus 3 plus M2 is given by 3 and X1 is given by 4 by M1 plus M2, that is 2 plus 3. This is the x coordinate of the point P. Let me also write here the y coordinate. It will be M1 Y2 plus M2 Y1. Y1 is minus 2 by again M1 plus M2, that's giving me 2 by 3. Let us remove this brackets. I'm getting minus 6 plus 12 by 5, and here I'm getting a 10 minus 6 by 5. So the coordinates become 6 by 5 and 4 by 5 when P is dividing AB internally. Let this be A, and I didn't write it here for convenience. Now we take up to find out, let me erase this part a bit. Yeah, now I'll make this use to find the coordinate for P, sorry, when it is dividing AB externally. So this part, this formula, the values for the M1, M2, X3, X2, they all remain same. We'll just be substituting it in the external dividing formula, which remains 2 into minus 3 into 4 by 2 plus 3. This is giving the x coordinate when it is externally dividing. And let me just make some space and write it here. So it will be 2, 5 minus 3 into minus 2 by 2 plus 3. Oh, I think I made a mistake here. There M1 minus M2. Let me check the formula, the previous page as well. Did I give you a wrong one? Oh, I'm so sorry. It remains as M1 minus M2 because it is externally dividing it. I then move on to rectify my mistake in the second part as well. Okay, now if I calculate this part, I think I'll get a minus 6 of minus 12. That gives me a minus 18, and this is give me a minus 1, so it remains as 18 only. And here it gives me a 10 minus of 6 gives me another 16 by minus 1, so that's giving a minus 16. So the coordinate where it is externally dividing the points, I'm getting 18 minus 16. So this being the case where these are the coordinates when P is dividing it internally, and then this is the one which is dividing AB, P dividing AB externally. Thank you.